Hello everyone. So in this video, uh, we are going to hack on, rather spy on the communication taking place between the inverter and the PC uh, through and this communication take place as we have seen in the last video through watch power software. So this spying will give us two things. Number one is the commands that are being sent from power software to the inverter and the CRC codes which are sent with these commands. So let's talk about what is actually this CRC. CRC stands for cyclic redundancy check, which means that whenever we send data, it has to be received in correctly. So there are characters added with your data sent, and these characters are calculated on the basis of data being sent. So every time there is new data, there is new CRC code. So the receiver and the sender both uses same calculation method. So if the data received has this on basis of that calculation uh, results in the same CRC that is being sent with the data, then it means the receiver thinks that the data is received correctly. So this is how it works. So with every command set, there is additional data, and these are additional bytes. Let's have a look at the commands. This is from the user manual or the communication manual. I will share those manuals with you. Look at this. This is the QPIGS. What I believe is Q stands for query, PI means protocol ID, and the GS is general status. So QPI GS. Okay, if you can see with the computer, it says PI QPI GS, and then there is a CRC. So this is the code that is sent, and after that CRC, we have a CR. CR stands for carriage return. Carriage return is, I think, from the typewriter era when you use this to move to next line. So carriage return in simple layman language today is the enter button. So it's like enter. Enter means that I have sent what I wanted to send. So the command followed by CRC, and after that CRC there is enter, which states which tells the receiver that what sender was sending has entered. So likewise, if you look at the device means that this is the answer when the computer sends the command QPIGS. It will receive this result, and the result starts with a round bracket, open round bracket, and then there will be N1, N2, N3, and then you see there is a dot. After N3 there is a dot, and then is N5. And what else you will notice that there is no N6, because in between N5 and N7 there is a space. So this you need to understand. And if I go to the table in the towards the bottom of the screen, you will see at CL number 2 it says N1, N2, N3 dot N5. This will give you grid voltage. Let's say we have like 220 volts here, so it will be 220.0 or .1, whatever it is. So from N1 to 3 dot and N5 I will get the grid voltage. Likewise N7, N8 dot N10 will give me the grid frequency. So the device will give me one accumulated string, and I have to break it according to my needs. So I hope that you can understand what I'm saying is that all the replies from the inverter will start with a bracket. This is constant. All you need to do is ignore this bracket, and then you need to uh, look at the CRC. There's an again CRC from the device at the end of the response, which means the device also sends the CRC so that the receiver can calculate and check that whether the data is received is correct or not. And again, after CRC, there is carriage return CR. So principally what we are saying is that in addition to response, inverter send us always uh, uh, four additional characters. One is the starting round bracket, CRC of two characters. I will share where I get this two, and then there is CR. So these four are additional characters, and the rest of it is the reply from the inverter. If you notice, in addition to capital N, there is small b, 83, b, 84, b, 85, b, 86, and so on. So these are bytes. This will be, the result will be either 0 or 1. So in the detailed menu, you will know what this 1 or 0 will represent. Right now, you need to understand that the B will, at the B point, it will be either 0 or 1. So I hope that you all understand that this communication take place in bits, right? So, and 8 bits makes 1 byte, and 1 byte actually represents 1 character. Like if I want to represent A will be converted into XC code. The code it may be 64 or 65, I don't recall, and then that 65 or 64 or A will be translated into binary, and binary will be of 8 bits, and that will be sent over through this communication. So I'm trying to address these questions because maybe because I'm trying to address non-technical people, and they would face these questions. So I hope that this explanation is good enough for them. Okay, the concept of this CRC and carriage return will help us when we go to Arduino code. For now, I think this understanding is enough that computer sends a command followed by CRC and a carriage return, and the device returns answers with the opening bracket, then answer followed by a CRC and CR. All right. So if we want to spy on what is being exchanged between our PC and inverter through watch power software, we need to spy on our serial monitor. So there is a software that is from Ultima software that is called serial port monitor. So this software helps us in getting the communication that is happening in between, and this is technically free because its use is 1 month. The first 1 month is free to utilize, but you see, we don't have to use this software or again and again. We don't have to spy again and again, because once we get the code, that is good enough for this tutorial or this project. So getting this software is simple and installing is simple, but still I will like to share. You can go to this website ultima.com and get the serial port monitor downloaded, and after that you need to install. Let's see how it is done. So it's very simple. I'm not doing anything special, and this system, and it is installed. Once it is installed, you click on continue demo, and there are so simple installation. All you have to do is click on continue demo at the end. I will explain this. Let's set up our Ultima software serial port monitor, and you should recall that we talked about 8N1 and 2400. That was the 8 bits of data, no parity, and 1 stop bit, and 2400 was the communication rate speed. So we will use these to set up this port monitor. So here I am starting the Ultima serial port monitor software, continue demo, and you can see I know my port 7. I will set the baud rate 2400, data bits 8, no parity, stop bits 1. That's it. This is what I need, and let's open a session COM7. I will open all the views, line view, dump view, terminal view, Modbus view, and let's start monitoring. And here we are, many windows. Look, keep the bottom left window, terminal window, shows us what is being sent and received, and this is the window in which we are mostly interested. So this is showing what is being sent. So let's see what we are getting. As in the terminal window, we have QPI with the 2 CRC codes, and in the top right we have the dump view. And dump view is showing us the hex values. We will talk about hex value later. The top left window, sorry, the bottom left window, terminal view, is the window we are interested in, and you can see what we can see. There are commands being sent, QPI, QMN. We just see what is being sent. We are not showing what is being received. So that is not a problem, because what we understand is that the Ultima serial monitor software is working. It has started monitoring the port. It has started capturing the data from the port, but there is an issue due to which the PC and the inverter has not started talking to each other. There is no reply, but at least we know that our serial port monitor has started working. So let's try to find out what is being sent and what is being received back. So in the terminal window, you can see that QPI is being sent, and we will start. We are not receiving anything, but now look at that NAKSS. This is the first response we have received from the inverter, and then there was PI30 whatever. Now what is NAKSS? NAKSS is good news. Whenever you receive this NAKSS, this is good news, because inverter is saying not acknowledged. Well, not acknowledged is why good news, because the commands you have sent to the inverter have been received. This means that your hardware connection is good, your CRC is passed, and PC and the inverter have started talking to each other. though they are talking in a different languages, they don't understand each other, but the status, but they are talking. They are trying to communicate. Even this NAK is good for Arduino and inverter communication. When you receive this means that you are almost done. You will start talking in any moment. Okay, so uh, like we discussed, whenever there is a reply, it starts with a bracket. So first round bracket we will ignore, then NAK, not acknowledge, and SS. SS is principally the CRC check, right? So the first bracket and the last two digits we have to ignore in a reply. So we are good to go. Let's have a look what else we are going to receive. See, there is much of junk, and you see here a lot of junk is being received. This is due to maybe communication error, but we have started receiving data from the inverter. We are not interested in the reply, but we are interested is what is being sent. If there is a reply, whatever it is, like this QPIRI230 and there is some junk, it doesn't matter, because inverter is replying. The inverter has accepted your QPIRI command. You can use this command in Arduino. If there is NAK not acknowledged, that means that command is not supported by your inverter. But if you are getting anything out of inverter, a reply, it means that command has been accepted, and this is good news. What else we need to do is we need to save the data in our terminal window, and for that we have to do whatever we need to do is right click on the window and choose export to. Let me show you how it is done. Right, so these are the replies we are receiving from the inverter. So lot of replies and garbage. Let's save this, right click, export to, and we have options type, but I would suggest it save as HTML. This will save the font colors. So all the data in terminal window will be saved. We can use this later. This includes our commands being sent along with the CRC and the replies we have received. So replies will tell us whether that command was accepted or rejected. Accepted means that we have a bracket and some text, and rejected means that we have a bracket with NAK, not acknowledged. Let's open our saved file and see what we have received and try to figure it out, the CRC codes. So this is the file, the HTML file we have saved, and I have opened it. So let me find Control F. Let me find Q. So let's have a look at what is being sent and received back, and open our saved HTML file. This is the file we have saved. So I have opened it, and let me do a search, and I want to search for QPIGS, and I say enter. Here is the QPIGS. This is the commands the PC sent or the watch power software sent. This was followed by a CRC, 2-character CRC dot and this copyright sign. So let's copy this and take this to Excel for further understanding. Okay, let's copy the code in a cell. So we have this dot and C, and let's separate these into two cells. Okay, so let's first get the XC code, ASCII code for this connector, and we have got 183 and 189. The next step is to convert this decimal into hex, and we will use the function hex to decimal to hex. And 183, the answer is B7 and A9. Remember this, B7 and A9. Now it's time to go online. So we need to go to online crccalc.com. So here is the website, and what we want is CRC calculator for Q. So it will be QPIGS. I am giving input in XC, that's fine, and I want the output in hex, that's also good. But I have some options like CRC 8, 16, 32, which one I want. So if I click on CRC 8, you will notice that in result I have 0x56. So 0x represents that the result is in hexadecimal. So I will ignore 0x, the actual result is 56. So there is one character, because in hexadecimal there are two digits to identify what it is representing, and 9C is another. So what I know from watch power communication and inverter, that they are using two character CRC. So this can't be, CRC 8 can't be my required. What about CRC 16? Yes, you see there are two characters, A6, A5, D7, 4E. So this is required, but let's have a look at 32. This has got 4 characters, and MD5, SHA, they are like strings. So let's get back to CRC 16. Hello, let's get back. Yeah, so here's the result with CRC 16. And if I look, there are different logarithms. So what I was looking for, let's have a look at our Excel. In Excel, we are looking for B7A9, right? So which logarithm is being used is the last one, CRC 16 X-MODEM. This is B7A9, right? So if you want to know CRC of any command, you can come to this website and you can type the text, the command over here, and at CRC 16 X-MODEM you will get its CRC code. So this is the second type of second method of getting the CRC code. The first method was sniffing this serial port. I will talk about there are two more methods. I will talk about them in upcoming videos, but all you need to do is remember this CRC and X-MODEM. This is the inverter CRC standard, and unless we use it, we will not even receive the not acknowledged response from the inverter. So this is necessary to remember and use. So we meet again in the next video.